Hello, everyone, and thank you for choosing to spend the next hour with us for our webinar, Top API Security Issues Found During POCs. We appreciate you. My name is Kristen. I'm the head of marketing over here at 42 Crunch, and today I'm joined by our field CTO, Isabel Mani, who'll be doing all of the heavy lifting for this presentation. Sure, you guys we have a lot of names I've seen before, so I'm sure you're familiar with us. Before we get started, just a few housekeeping items. Everyone will be muted throughout the presentation to avoid disruption. If you have any questions, please enter them in the Q&A and not the chat. The Q&A will go through those first, and then if we do get some in chat, I'll try to get to those as well. But please use the Q&A. We'll address all the questions, or as many we can get through, at the end of the presentation. If we don't get to your question, don't worry. We do a follow-up blog for every webinar, and we answer all the Q&A in there. This session is also being recorded, and everybody will get a follow-up email with a link to the recording, as well as the blog. All right, guys, that was short and sweet. Now let's get to why you're really here. Isabel, it's all yours. Cheers.
Thank you very much. Good morning, good afternoon, wherever you are in the world today. So yes, I'm Isabel, happy to be here with you all. Just a word of caution before we start. I'm here in what used to be sunny Spain, but today there's a lot of storms brewing. So if you hear some weird noises and cracks during the presentation, that's because there's this big storm preparing around my house. And hopefully the power will not cut. We'll see. So yeah, we decided to create this webinar and present this webinar after working with a lot of prospects on proof of concepts. So that give you an idea, I think those are pretty representative of the type of problems that our tools are finding in real situations and with the real APIs. And share a bit what are the top 5 of problems that we see again and again, and what basically, more importantly, you have to do about them, right? So before we do that, just for the sake of people on this call who are not so familiar with what we do and basically what happens in a 42 Crunch POC. Well, in the 42 Crunch POC, we basically use the platform to do a number of things on API definitions written in OpenAPI and or Swagger format and specification. So this starts at development time. So the first tool the first service of the platform that we use in a POC is what we call the audit. And we'll get into the details of what it does, but at a high level, keep in mind what this is going to do is going to take an OpenAPI Swagger file, like a static file. And it's going to analyze its contents along a different set of access for security, for data formats, for compliance with the spec. And the idea is that at the end of the development phase, we have a very strong contract that really describes in very much details what the API does, how is it secured, how you can invoke it, what are the mandatory headers, the mandatory parameters, the data coming in, the responses coming out. We have something very thorough that really describes all the in and outs of our API, right? And this can be done interactively from my IDE, from a CI/CD pipeline, from our SaaS platform. There's all different ways of doing that audit, depending on who you are and how you want to actually execute this. But at the end of that, the idea is that as early as possible in the life cycle of the API, we're going to do this analysis. Maybe we don't even have the implementation of the API yet. Maybe we're taking an API first type of approach, and we'll generate the implementation later. But right there from the beginning of the development phase of the API, we'll be able to have this like fair idea of how good our interface is, right? Then the next stage is most likely at integration and testing. What's going to happen is we're going to enforce this quality of our contract through the CI/CD pipeline. So whenever a developer just pushes their code to our Bitbucket or GitHub or GitLab, whichever system you're using to store your source code, will have some pipeline that will be started in Azure DevOps or in Jenkins or in Bamboo or GitHub Actions or GitLab again. It's a pretty fragmented world. There's different ways of doing it, but the idea is there you put a point of control where you're going to enforce, certain rules in terms of, okay, if some minimal security requirements are not met, like it can be the score, it can be some specific errors that we find in this audit, we're going to block basically deployment just to make sure that we always reach the minimal security requirements that have been set at the enterprise level by the security teams in general. And make sure we don't let some APIs that are not reaching those minimal requirements go through the next stage, right? So we want to catch those problems as early as possible in the life cycle so that it costs us less effort to actually fix those. And companion to that is what we call the conformance scan. So what this is really is, okay, you're telling me this is your contract now. I've done a static analysis if you want. I've done an analysis of something which is static, which is a static file, a JSON or YAML file. Now point me to an implementation of that API and I will tell you how faithful is this implementation compared to that contract you're giving me. So I will try to invoke the API with good data, with bad data, and see how it reacts and see if all the different responses that I get actually match what the contracts say. Is there any response codes that we forgot, or is the schema really that I'm being told is the good one for error 400 is really the one that I found in the contract? We'll get into more details, but the idea is really to make sure that the implementation is in line with the contract, or vice versa. The contract is in line with the implementation. Maybe it's the contract we got wrong and we have to go and correct. Maybe it's the implementation that has some problems that we will have to go and fix, right? That will allow you automatically to generate all those problems and see how your API is reacting to those problematic payloads, right? And finally, in a POC, what we're going to do is deploy a protection in front of our API with the same information, with the same open API file, same API contract. I'm going to use that and say, okay, you told me it's what your API does. I'm going to sit there in a line of traffic, and I'm going to ensure that nothing that does not match this specific file actually can go through. So it's a positive whitelisting type approach in terms of security, where I'm going to make sure that the information that flows through is actually totally conformant to the actual contract that has been defined. And all those three services kind of feed each other, as we will see, because the idea, of course, is that at the audit time, you actually create the best contract, the most precise possible, so that the whitelisting is actually very precise as well, okay? And the more precise the whitelisting, the better, and we don't have to the better, right? So let's close it that at the high level of the platform. That's basically what we do, okay? So in terms of the auditing, what are we going to do on the Open API? So at a high level, what this does is it will take the file and it will analyze it along three different axes. It will look at whether it's actually conformant to the standard. It will look at the security definition, and it will look at data definition, right? So this is like a universal language. If you haven't used OpenAPI or Swagger before, I hope you all do. But the key, really, what we see first of all in POCs, is what we're here to talk about, is all the customers obviously we work with have standardized on OpenAPI across the board, and this for multiple reasons, right? First of all, because it's a fragmented world from a development point of view. And basically the only common language across all those is OpenAPI today. So if I'm a developer and I'm creating my APIs in Bootstrap or in Spring Boot or in Java or in pure Node.js, whatever it is, right? at the end of the day, I'm going to get some code that does things, and the way to describe what this is doing is through OpenAPI, right? And I can generate that from the code through annotations. I can have specialized tools to actually generate that file. Doesn't really matter, right? In a sense, the important thing is that I really have this ability to govern all my APIs across the board and have this, homogeneous view, I would say, across all those different environments, independently from what the developers are actually using, right? And I can compare also. That's very important, as you will see in the audit, to have this single view, so I can compare the level of security of one or the other, independently, again, on how the actual implementation is actually done, right? And again, we've done this in a way that it can be plugged into IDEs and pipelines and automated. So every time you push the code, then it will happen. And what people really like about this in the POCs that we do is it's a very actionable report. So the report that you get of this is usually a zero false positive, because it's a very objective analysis, I would say, of what is described there, right? And if something, people say, but that's not the way our API works. So, well, that's the way you have described it. That's all I know about it, right? So if you've described it well, then we know exactly what it does, and there should not be any false positives. So this is what it looks like. Overall, I have a score over 100. Okay, so in this specific case, I have this API that has a score of 13. Okay, and the score of 100, you start from 100 points, right? When you start the audit, and as more and more problems are adding up, then we subtract from this 100. That's the way it works. So you don't gain points, you lose them, basically. And by fixing problems, then you regain those points and the score. So out of those 100 points, 30 points are assigned for the security section, and 70 points are assigned to the data section. So how well did you describe the data? Because it's kind of a core to a lot of problems we're going to describe now. And what behind the scenes, so you know how this works. Behind the scenes, what happens is we take this Swagger file, OpenAPI file, we send it to our platform. This audit happens and comes back a JSON format report. So what we generate out of the tool is a report in JSON format, so that you can then analyze it the way you want. You can display it as we're seeing now. We can display it in an IDE. You can consume it yourself to do your own analysis. We're working, for example, right now for a specific POC on the SonarQube plugin. So there's all different ways of consuming that information, okay? So first thing, I'll do the demo in a minute. So some statistics first. Since we started working with customers, I've probably worked in most of the POCs that we've been doing, and I counted something around 3,000 Swagger files we've been looking at and analyzing. Some customers have been importing 3 and 4. Others have been importing 500. It depends on the size of the customer and what they want to do as part of the POC. But at the high level, what we see is about 20–25% of those are actually invalid against the spec. Either because you don't follow the spec for some reason, there's a mistake in the schema validation to make it a valid OpenAPI file, or because they have structural, semantical issues. They're missing some information which is required. Some schemas are not right. There's all kind of different problems. But it's interesting to see that no other tool has actually caught those problems, which is one of the things that usually surprises people. Is say, what do you mean, right? Because it's been through different tools, and nobody ever told us that this was not allowed, or this was a semantic issue or invalid. So our validator, I think, is extremely strict. Something we have written ourselves in Go, and as part of the platform, it's maybe stricter probably from POC results than a lot of the validators which are out there. So don't be surprised if you try the tool and it tells you that the file is invalid. You're not alone. But as I said, one person and one file and 4 is actually deemed as invalid. And it's usually it's a detail or something, but we're right. And the other thing is the average score. So when people push their files into our audit, the lowest score I've seen so far is 1. To be frank, I think we're very nice and we don't want to put you a 0, so we don't despair people. But it had 25,000. I've seen things with 13,000, 20,000 issues in there, like very large files. All right, and the highest has been 70, right? So across all the POCs. So average, depending across the thing, I would say is about 25. So what happens with this is this. That's the best picture to actually explain what people see, which is what, we thought we were actually good. What is all the stuff that you're finding and nobody has found before? Right, and what all those problems that you're raising. So let's have a look at some, right? So the first one, as I said, we're looking at security and we're looking at data, right? So the first thing is security definition. So in many cases, the security definition is not there, right? And we've traced back to some tools, for example, that don't inject it automatically unless you say it and you configure it to actually do so, or simply people forget about putting that in there because they've put it in the documentation, so they don't put it in the file, and so it's missing in quite a lot of cases, right? So it's not like security is not there in many cases, and most of them, but it's not there in the file. Or the secure section is defined, so it's there. There's a security definition, but it's not applied either at the API or at the operation level. So it's as if you had not, well, it's defined, but if it's not applied, then it cannot be, we don't know what it applies to. You can have multiple definitions in a single file. You could have part of the file with some specific tokens. We can have part of the file with OAuth. You can do that. So the Open API definition allows you to do that. So it's usually, in many cases, it's actually lacking. Now, when it's there, what are people doing, right? So there's a lot of API key protection out there. And one of the things we're going to tell you when you use API keys are similar. So it can be people generate a JSON web token and use it as an access token. It's not OAuth based, so you don't have the OAuth dance to obtain an access token. It's more like the server code that generates a JWT and through a login, for example, and then asks that access token to be passed in all the other operations. That's one way of doing it. Or so we see that a lot. And one of the things we're going to tell you when this happens is this thing you see at the bottom that says credentials are transported over the network. And really what this means is just to more like bring your attention to the fact that if you're using long-lived credentials, and it can be basic auth as well, API keys or access token, we don't know how long they're going to be valid and working. Your exposure to the fact that this can be stolen or lost or etc. is much higher than if you're using an access token which has a short lifetime, right? So that's one of the things about OAuth is if you're using properly OAuth, you should not have any secret information flying around, only public information flying around. So if you're using API keys, we see API keys being transported in query instead of a header, for example. So if it's in a query, it's going to be in every log, in every access, every proxy you go through, that's going to be in the logs of that proxy because it's in the URL. So all of this, we're going to, tell you, hey, are you sure you want to do this, right? Now, that's pretty common. And the other one that we see appearing is HMAC-based signatures. So basically this, we have also seen that quite often in the banking industry with open banking, on saying, okay, well, for every single request, basically you'll have to prove who you are by, I'm going to give you this, symmetric or asymmetric key pair, and every single request will have to be signed. So I'm going to sign the body, you're going to sign some headers, different ways of doing this, and where you're going to put the signature in the header, in the body itself. There are multiple ways of doing that, but the idea is that you're using, you know, a maybe stricter way of enforcing something which is not based on, you know, having a key which is moving around. Like there is no key moving around here. There's just a validation happening on both sides, an operation happening on both sides. And what you transport is the signature, is not the key itself, right? So unfortunately, this is not something that you can describe with OpenAPI today, but I'm actually putting a plug here for some work we're doing with the OpenAPI Foundation initiative, which is to be able to describe that in OpenAPI. So if you're interested, this is something that you're using and you can't find a way to actually describe it, and you would like to, you know, bring your vote to this or put some comments, please do on that issue in GitHub for the OpenAPI specification, so we can push the ability to describe such security into the actual specification. Okay. Now, why is this important, right? I still see out of those POCs, so it depends also, of course, of the customer and their maturity in that matter, but API keys, auth, we still see a lot of, confusion might not be the right word here, but obviously it's much easier to manipulate API keys. You go to a site, you click on the button, you get a key, you go back to your code, you put that key somewhere, job done, right? That's actually easier from a consumer point of view and also from a provider point of view to actually consume an API. Now, whether you're gonna bring auth here into the picture or not is gonna really depend on I would say sensitivity and risk, right, at the end of the day. So if that API key is lost, is found in an app that has been decompiled, an Android app, where it's kind of, you know, buried there in the code itself, or if it's, you know, seen through a query or anything in logs or stolen, what can happen, right? So if somebody is using that to exploit your API, what can data they can get to? Well, because the other big difference I would say between a normal API key, like a basic API key and OAuth, is all about controlling the resources that you have access with this API key. So if I have an API key, is it valid for all your APIs? If you have 10 APIs, 20 APIs, 100 APIs, can I access all of them with the same key, right? Or is it very restricted to what I can do, right? Does it have the equivalent of scopes, I would say, behind the scenes? So it's all about, like much of security, it's all about risk and the protection of your API and what is it you want to do versus the simplicity of usage for your consumers, whether they're able to, they should all be able to do auth now because of the so many libraries that allow you to do this pretty easily. So yeah, it's all about looking at the risk and making an informed decision on what is best for you and your consumers. But one thing, if you're going to auth, one of the key things, and in the evolution of auth, which is now 10 years old, right? We started with multiple ways of obtaining an access token, and basically now there's really an agreement that there's only really one that you should use. Should you do single page application, mobile applications, or web applications, authorization code is the way to go, right? And if possible, using PXE if your provider supports that, which they should, so that you never have private information, the secrets flying around ever. It can be stolen. You have additional security with PXE, etc. Right? So PXE was reserved for mobile application at some point, but now there's kind of an agreement that, you know, we should just use it for all type of applications. So in all doubt, start with this one. There's another grant, which is a device grant, which is a specific one for specific devices, which probably depends again on the type of applications and who are your consumers, but something that was invented for the the top box, like the Netflixes and what Canal Plus of this world, right? But in general, that's probably authorization code is the one that you want to use. Okay, so that's about security. It's like defining what is it that I want. Is it API key? Is it auth? And describe it well on there. Now, the next big thing that we find all the time is how well or not data is actually being described, right? And usually it's not. That's where, frankly, most people lose most of their points. If they have an API key, they will have 15 points out of the 30. And then they will have 3, 4, or 5 points on the data side, which is where we get to that 20 points average, right? And the problem is that in general, the schemas, either inbound or outbound, are very loosely defined, right? So while there is information usually in more in the headers or in the query parameters, there's more like constraint at that level. The schemas are actually very, very loose, right? So that means we have strings and we don't know what the format of those strings are. We have unbounded numbers. We have unbounded array sizes. So we don't say that when we return some data to a client, are we going to return 5 or 10 or 10,000 items in that array, right? Or same thing inbound. And all of this is very critical to protect from some of the OWASP top 10 for APIs that you all came to know and love now, right? It's important for data leakage, making sure we don't send back more information that we want to, or extra information, or we have in those fields things that should not be there. Overflow protection, the other way around. So I cannot send you a string which is 1 million characters when you're waiting for 8, right? And of course, anything related to injection. So in general, this is the core to validation of inputs and outputs, right? We always talk about input validation. It's also very critical for APIs to do output validation and making sure that whatever we return through our API is actually controlled, right? And we know what we're returning and why we're returning it. And what we've seen as well, it's an interesting part, is it's not like people don't know what the format is, right? It's just that the information is in the documentation. So I've seen this too many times to count now, where you have a description that tells you what the format is, but the schema does not. So unfortunately, when I do schema validation, I cannot read the description and extract that, oh, this is a UID, so I have to validate as a UID. I have no idea it's a UID, right? Same thing for here, an account group, right? So values include check-ins and savings. Okay, so rather than putting it in the description, what you want to do is instead putting it as constraints, right? So you can still keep the description, of course, no problem with that. But you want to put that as constraints to that schema. Why? Because now when this UID header, or if it's in a schema, comes in, I know exactly what I'm expecting. I'm expecting a UID, and this is the pattern for UID. It has a very well-defined UID v4 has a very well-defined pattern, right? And that pattern, if this is not what I'm expecting, it has to be 36 characters, cannot be more or less, right? That's the minimum, that's the maximum. And it has that pattern. So if I do a validation now against that schema entry, if anything else is trying to come in or come out that does not validate, that's not basically conformant to that, it should be deemed as invalid, right? So rather than, I've been to a customer here about 6 or 9 months ago now, where they told me, oh, we know all that information, and they just pulled this 120 pages PDF document that had every single field defined with the regexes, with the constraints, but in PDF, right? It's like, well, basically what you have to do now is take all that PDF and put it into an open API file. And that's exactly why, I'm just operating a parenthesis here, but that's exactly why OpenAPI and such specifications were created, so that you can describe this information in an actionable, automated format, right? So I can automate things out of that static description, such as validations, right? And then if you have it all there in a schema, in something which is static, that you can put in your GitHub, that you can diff and version and compare. Somebody was telling us a few days ago, the key advantage of that as well is I have a developer, I'm using, outsourcing, and some developer has to leave and a new one comes on board. Well, I have all this information of exactly what the API is doing in a single place, in a single file. So it only has advantages, I think. It has the advantage of having this unified description. From that, you can generate a fantastic online documentation. You can do automatic validations. You can do a lot of stuff, right? So just take whatever and that's exactly what we're pushing people to do in our platform. Just take your knowledge about this data, and it could be in the business analyst, it can be the developers, and just put it all in that file, right? And then it will be, your life will become so much easier, right? Plus whatever we're going to bring you on top of that, right? So this is the first thing. Now the other thing we've seen, and we see that a lot, is you guys are super good. You only create APIs that don't fail, which is fantastic. What I mean by that is I've seen the structure you see here, I don't know how many times now. So you have a path, okay, I have an operation. It says it produces application JSON, okay. But then here it says responses 200, okay, fantastic. And that's the only response I have, and I don't have any more responses. And it has no data, right? So you don't return data, which could be true, right? But it's probably a 202 you want to put instead of 200 that happens. That's debatable. We can. But most of the time when we do it on POC, it's not because the API actually does not return data. It's because the schema has not been attached to that actual response. And then from a standard point of view, this file is absolutely, what you see here on the screen is absolutely valid from a specification point of view, except it's quite poor for the consumer, again, on, okay, you're going to send me a 200, and then what? What am I supposed to receive? Am I going to receive, you're telling me I'm going to receive some JSON, because it says here produces JSON, but what JSON am I going to receive? How do I validate that what you're sending me is actually valid from a client perspective, right? So one, we want to make sure that we return data with our 200. If we return data, we want to describe it, right? And then we want to make sure that every single type of responses that we can receive is actually described, right? So you have security. Well, you should have a 401 most likely, maybe a 403. You have rate limiting. So probably you have 429, because all the rate limiting API gateways, and I know, for example, that's what they will do. They will return a 429 saying, hey, you reached the limit of what is allowed for this API, and come back later, right? You have 415 to say what's the data in the format of the data in the body. 405 to say that a method is not allowed. 403 to say you're not authorized, etc. And if you don't want to, imagine I had a prospect tell me this. I said, well, whatever I return, it's always the same response. So basically, I have a standard error response in which I put the status code and what happened, and some details about the problem. Okay, you want to do that? No problem. But then what you have to do is you say default response. There's something to that. So the third one in that line, and say my default response is this error structure, right? And whichever code, whatever is the code, we have harmonized everything. We'll always send back the same error structure by default, okay? And then we have something to describe that, and it's called a default response, right? So that is something that we will test also later, but it's very, very common that we don't see much of non-successful response codes being described out of the box, right? So yes, all of these really matter, right? So what are you going to return? And again, this is linked to another key OWASP problem, which is data leakage and exception leakage. So if you don't describe all the codes, if you don't know what you're going to describe to return, how can you enforce that you're not leaking data that you don't want to leak, or exceptions, or anything you don't want to go outside? So if I'm a hacker and I'm fishing around and sending you bad data, or pulling from a string that I found to extract and do some data scraping through your API, how do you protect yourself from that if you don't basically control your responses, right? So which one are valid? Are all the error codes valid? Like, is it normal that I get to 500 or 502 or not? Should it be caught on server side and wrapped around something else? So you really need to control your responses, right? So as I tell everybody, just take ownership of your schemas. There's one thing I see across the board is the schemas are really loose, very well described, and not strict enough. And more importantly is, and that's something I wanted to show you now, your schemas need to be strict, right? Because otherwise, even if you validate against them, then it's kind of, not as good as if you have some limits on those, right? So let me show you this. And this is nothing to do with 42 Crunch, right? This is an editor. I'm going to show you in here, right? So you see here, I have this schema, just very simple. This is something that just calls a library behind the scenes, something online you can use if you want to, where I have a schema and I have some input JSON, okay? So obviously, all those patterns and limits you have in here. So if I'm removing this, right, I have here a user pattern and it says this is an email, right? So if I put something in here which is not an email, right, this is going to tell me, hey, that doesn't match the pattern, so no, I don't want it. It is not valid, right? But obviously, if you don't have any of those that usually we don't see, right? So if you have something like this, then there's no problem at all. I can put anything I want in here, dollars and question marks, and well, maybe not this way because I've put something I shouldn't put in there. But I can put all kind of stuff in there that have nothing to do with the username, and that's the open door to those injections and those problems. Because even if within your code, within your API management, you have a building block that says JSON validation, right? And you're validating what comes here against a schema, which is not strict enough, right? It's not as if, because you still have the strict here for the fact that it's required or not. But as you can see, of course, I can inject all kind of stuff in there that I cannot inject if I put all those limits, right? So one of the key thing I think that make people think when they get the result of the audit is it's hard for them to ensure, say, are you sure you're doing this today? Where in your code are you making sure that all the data you're receiving or sending back is actually valid according to what you want, right? Where are you doing this? Is it in the code? Is it in your gateways? Is it somewhere else? Where are you doing this? And which schemas are you using for doing it, right? So that's a critical thing. And of course, it's the same on requests. So when I'm receiving a request, all the schemas and everything also need to be strict, just to make sure that I'm not accepting data that I'm not supposed to accept. So I don't know if you, some of you were on a recent webinar that we did on some key API breaches, but one of the ones I've shown is something that allows you, by injecting just another JSON property, to make yourself the administration of a system, because there is behind the scenes something that says is admin and is a Boolean, right? So I'm not supposed to be able to do a mass assignment and override and say is admin true, but because there is no constraint on that schema, and that says, well, the only thing you can put in there is whatever has been defined, then you can actually do that. So one of the key things to look at, and frankly, in OpenAPI, between version 2 and version 3, it's a bit, look at this closely, is this notion of additional properties, right? So you have this notion of additional properties being true, being false. The defaults have changed across the two. So just, you know, make it obvious in the file, additional properties false, this is what you want. Just to make sure that if somebody comes in and tries to inject extra information, it actually cannot be done, right? And one of the key thing as well is make sure that you expose, so that's true either for request or responses, right? The third point here. We tend to want to expose APIs with a single API for multiple type of consumers and multiple consuming patterns, right? So I have this get whatever resource foo, right? And it will give me all the information about resource foo, and then we'll say, well, the client, depending on who they are, they will just pick inside my response, which has 30, 50 fields, whatever it is, whatever is interesting to them, right? And same thing the other way around, we'll accept something that can update a resource, and depending on what the client is, they can put 3 fields, 2 fields, 5 fields, and they will be able to update. If it's an internal user, then they can update more. If it's an external, we'll update less. So frankly, it will be much easier to control. So it's a bit more work because you will have multiple APIs to basically create and manage. But from a security point of view, just to make sure you expose and you receive only what you want to, right? That's actually more controllable this way. There's more governance that way, right? And something which a lot of people don't really think about as well on massive stuff is network traffic, right? So when you this data systematically, so I'm sending me 150 fields through an API, one way or another, and I'm actually consuming 3. This is like a loss of performance and network traffic that you know, on both sides, both from a client perspective and from a server perspective. So optimizing those APIs and what you expose is actually beneficial also from that point of view. Okay. Now, from a scan perspective, this is kind of what the overall findings for the audit are, okay? Now, from a scan perspective, again, what the scan will do is it will say, okay, now you told me this is my contract, that's all it does. Now we're gonna go and invoke the API based on that contract and see how well it conforms to the contract. So what the scan will do is it will first do what we call a happy path request. It will use the samples within the API, for example, the OpenAPI file, to do one or multiple happy path requests for every operation. And then they will start sending all kind of bad data to your API to see how it actually behaves, right? And you will see things like this. That's a sample report. What we will do here is so sending verbs which are not supposed to be allowed. So this specific API here, it takes a post, and we've tried a delete, a get, a head, option, etc. And all of these failed because they were accepted, although they should have been rejected. The only thing that the API is supposed to support is a post and nothing more. Then we'll try to inject improper content types, improper types. So here in this screenshot, you see injecting a Boolean instanting an object. And what will happen is what you see here on the screen, where we will then realize if the API is actually strong in terms of, I would say, error handling, right? And exception handling and input parsing, etc. Because that's the way you're going to find, I would say, 3 things. First of all is how well does the API validate the data coming in? We're back to the validation again, right? Does it accept blindly of the data coming our way? Now, one thing to keep in mind here, you may have to dive into the frameworks that you're using to understand why something that we're seeing on the screen is actually happening. Because it might be that it's your framework that receives some, Boolean in this case, instead of when it's expecting JSON, and just automatically just goes and reacts without giving you the chance to actually capture this and wrap it under your error code. So the only way you're going to know, again, is because you're going to try, right? So that's one thing we've seen is managing the bad content types. And when I'm saying bad content types, it's handling an existing, so a valid MIME type, let's say content type application XML, right? But that you're expecting JSON. What will happen in that case? Or what will happen if I'm sending you something and has no, apart from the structure maybe, that is not a valid content type. So I'm sending you whatever, text/foo, right? So that is not supposed to be there. And we've seen in POCs those frameworks reacting differently depending on that. So the reaction could be that it's properly caught when it's an invalid one, like a non-existing one, but not when it's not the one we expect, for example. But again, the only way you're going to know is if you try, right? That's the only way you're going to know about this. So what are the most problematic things we see with the conformance scan? First of all is indeed error management. So we receive some, the bad data basically triggers some, for example, a response in HTML as the one that we have seen before, which of course is not part of the contract. Or we're going to discover that we're returning some unknown response codes or schemas which are actually not the proper ones. So that's another thing the scan is going to do, is when a response comes back, we will make sure that the response that comes back, again, is valid according to the contract. That's really what the scan is doing, right? Is making sure that the implementation is in line with the contract. So anything that is not a match is all the things that we're going to report as part of the conformance scan report, right? All those problems. And it's back, I think, to the same root of the problem, which is it's really hard today to do testing along those lines with APIs. You don't really have an automated way to create all those bad requests with bad data, bad token, bad information automatically, such as you can test how your API is actually handling all those error cases, right? But as I was mentioning, I think it was last week in another discussion, for every single functional test that you do, you should really generate 5, 10 breaking tests. So things where you're sending bad information to see how the API is actually reacting. And that's what the scan is going to do automatically for you. Now, but the good news is, right, if you have created your open API file, and if you have generated and fixed, and remediated all the problems that we have discovered at audit time, now what do you have? Well, you have an open API specification that thoroughly describes every single piece of data flowing through the API, every single operation, what it does, every header, every query parameter. You have strict schemas now, so nothing that is not proper is not going to go through. So that is the core of this positive security model I was talking about. So your next step in the POCs really, and that's the easiest step I would say, is most of the time in a POC is spent on the first aspect of everything, which is creating that open API file, which conforms to what your API is actually doing. Because from there, we can do the scan automatically, and from there, we will do that whitelist for the runtime automatically, right? So this open API file that your developers, your business analysts, and everybody has contributed to make the best possible now becomes the heart of our API firewall. It becomes the configuration of the firewall that will make sure that nothing that doesn't conform to that actually can go through at runtime. So there is no need to do maybe a more blacklist type approach. There's no need to try to guess what the traffic is going to be, or learn to the traffic. You don't need to learn, because that's what the Open API specification says, right? So this is the easiest part actually of the POC, because that configuration is already done. There is no rules to write, so that's the easiest. There's no problems there. So if I could conclude based on everything that we see, right? The core problem really is, I know governance is not a word that people like. It's never, governance sounds like processes and complexity and everything, but security requires governance. So you need to really strengthen, start by strengthening your API contracts, right? So we have this luxury, frankly, in the API world, to have this de facto standard, which is adopted by every single vendor you can think about. You have dozens of tools, dozens of frameworks, everybody supports it. So it's really the form that allows you to, we're going to be the source of your docs, of your definition of your code. It's your API first, and now it's also the source for security, right? So just make sure this file represents what your API does. Even if you don't use 42 Crunch, right? You will have strong, at runtime, right? You will have strong schemas to use that you can enforce through JSON schemas, even in your code, right? But use the audit and use the scan to discover those problems, then use the firewall if you want to do the protection as well. Anyway, the call to action I can give to you is use this unique audit functionality to evaluate your contracts today, see where you fit in those average scores that I gave. You can do this for free today on our API Security.io website, or you can also download our VS Code extension and start firing away and see what we report on your files, and see how you fit in the average of the people we work with. And that's what I had for all of you today.
Thanks, Isabel. So we'll take some questions. If you guys have any questions, please enter them into the Q&A. We have one right now. Is there a way to whitelist specific rules?
Audit rules, you mean? I assume. So we get the question a lot, which is you have a set of 200 checks, right? And some of them don't apply to us, basically, right? So there are some annotations that allow you to influence the score, I would say, especially on the security level, right? So allow to say, well, my definition of security is not one that, for example, Open API allows me to describe. So trust me, I know what I'm doing. I put a notation in there, and you get your 30 points. But that's basically saying 42 Crunch. I'm in charge here, and I know what I'm doing. So it's okay. Give me credit for what I've done in my API, right? There's also the ability to change the sensitivity of operations. So the way the score is calculated today is by taking the approach that your API and all your operation are at the same level of sensitivity, right? So if you have an operation where some of the things that we report on schemas are less important in your view, because you consider that the risk of something happening is lower, or on the contrary higher, you could annotate that operation with this sensitivity tag, which will influence the count of points that you lose or you gain depending on the rules. Okay. Now, individually, there's no way today to turn off or turn on additional rules. This is something that a lot of customers are asking for, and something we're looking at and being able to do. There's a way in CI/CD that we're finishing now to block the deployment on specific rules. So kind of say, well, for me, customer A, these 3 rows are super critical to me in my business, but those 5s are really not. So that's something you could say, but there's no way to turn on and off individual rows at this point.
All right, thanks, Isabel. Next question is, what are the parameters in Open API for API Firewall, and how do you configure that?
There's no specific parameters for the firewall. So we consume the Open API file as is, right? So we'll just interpret directly the Open API instructions. That's for the whitelisting. Now, what you can also do in the firewall, I'm not talking about here, it's kind of beyond what we're saying, we'll do that in another webinar soon, is how to extend and annotate your Open API for extra functionality. So such as saying, I want to do, on every response, I want to inject automatically security headers, or I want to validate the JSON Web Token based on best practices 8725. So that's something that we're going to do, and those are extra protection. But out of the box, the whole whitelisting approach is just consuming natively the standard Open API. There's nothing else you have to put in there.
All right, great. Next question. I'm using the VS Code extension, but it fails every time since a path is not defined. Is there a way to still run tests even though there is no path defined?
Well, if you have no path defined, you don't have a valid Open API file. You should open, we should probably give you a better, I guess, feedback if this is not what you see as a response. But from a specification point of view, you must have at least 1 path and 1 verb defined. There's a minimal set that you have to have defined for the audit to actually run. But again, open a ticket on GitHub, which is attached to the extension, and we'll have a look and fix it if there is a problem there.
All right, we'll take one more question since we're coming up on the hour. How do you do security testing on API-driven applications via Lambda functions for beginners in API security?
Can you repeat the end of that? Sorry.
How do you do security testing on API-driven application via Lambda functions for beginners in API security?
Oh, okay. Well, we don't, so make sure I understand correctly your question. We have some customers doing Lambda today. What they do is they expose their Lambda functions through the Amazon gateway, API gateway. And then for us, at the end, it's just an endpoint, right? So what the Open API file will have to describe what this API does. Should it be implemented with Lambda or something else? At our level, we don't see that, right? Because in the audit, we will see the Open API file, which is standard and is independent from the implementation. And at the scan level, we will see a URL, an endpoint to talk to that implements that actual interface, right? So we kind of independent, if you want, from those point of view, from whether this is Lambda or something else. And I hope I understood the question. Otherwise, please send me a mail and I'll precise.
All right, great. All right, guys, well, we're hitting the top of the hour. Thank you for joining us. And as soon as the recording and our Q&A blog is up, I will send you all follow-up emails so you can have access to the materials. Hope everybody has a great day. Thanks, Isabel.
Thank you, Kristen. Thank you, everyone, and have a great day. And thank you for joining us again. Take care.